Hello, good evening. In this short video, I'll be explaining about assignment 2 of statistical machine learning for data science. And this assignment was comprised of two parts. The first part was practical statistical machine learning on DNA macroarrays. The second part was regarding the nearest neighbors method for digital cognition. Now, starting with the first part, we had a dataset called prostat in a CSV file. So I'm going to share my R code here. So this is the first, I loaded the dataset. But before that, of course, I needed to load all the required libraries in this task. So these are most of the library that I'll be using in this task. And so this is my data set basically. So it's prostat, and then I click the view, I run this view, and I can have a look at my data set here. So this is my data set. As you can see, it has 501 columns, but in this 501, the first column is the response. And we can clearly see that the response is just a bunch of zeros and ones, meaning in this question, we are dealing with a classification task because the response variable y is a binary. So it has in binary labels, zeros and ones on it. And we can see that we have 79 rows. So my input space is 79. Now, so about the shape of the data, we have already said it's 79 rows and 500 columns. Out of these, only one is the response, and the 500 are the predictors. Now, this is my data set, my variables in the data set. You can see that all these ones are, of course, they are numerical variables, and they are taking random values. So they are continuous and numerical variables. Now, coming to the bar plot, you can see that the bar plot for the response, the higher number one, so one is a label for cancer and zero is a label for non-cancer. You can see that label one has a higher frequency than label two. And next task was to plot the 9 most powerful. As you can see, this data set is very large, so we can't use all the variables. And then in this task, we used the so-called Kruskal-Wallis test to find the 9 most powerful predictors. And this means that we can just use these 9 instead of using the whole variables because some of the variables are insignificant, are not significant. So these are the variables I got, and these are the test statistics. As you can see, this first variable x217844 underscore add as 14.90 test statistic, and this was the rank. And then this is the plot basically. You can see that this one has the highest one, so but around 14 point something, and so on up to this one. Next, the box plot for the 9 most powerful. I opened this box plot in the next window. So this was the box plot. As you can see, the first variable, x217, this one, has, we said it has a high test statistic. So as you can see, compared to the response, it's clearly separating both of them. And so that's why it's the first one. And we can see that the other ones also follow. This one, the box plot, this is the box plot for each variable with respect to the response variable y. Next, we have so some of the comments in the box plot you can see. So for some of the variables, and there is noticeable separation, of course, medians of two classes. Yes, that's what I was basically saying. Like, for example, on this variable, you can see that the two medians on both classes are separated, even here, even here. That's basically what I meant. Yes. Now, the next task was to build a classification tree. This is just one line of code. You have a response variable here, and the data is, and then you use this function alpha to control. Now, plotting the tree, this is, yes, this is the code for plotting the tree, and this will return the number of nodes in the tree. And in this second, you can see that we have 8. You can see that we have, sorry, not 8, it's 9 actually. You can see that we have 9 variables, not variables, sorry, number of terminal nodes. And this is how my tree looks like. So this is the first region, and this is the second region. So I go like this, like this, like this. So this is the first region, second region, and then the last region. So you can clearly count those number of terminal nodes. And so I think I won't be able to cover the remaining part of this question, but this was the first part basically. So the first part was just a bit of yeah, doing some box plots, some test statistics. Yeah, this was what the first part was roughly. So it's up to up to here, up to trees basically. And then you do the box plot for the 9 weakest variable, and yeah, and the correlation plot. Yeah, if I were to show you the correlation plot, it's something like this. So yeah, something like this. And then you can see that for the dark blue regions, we have a strong correlation, of course, and then these dark brown regions are negatively correlated. And these ones that almost look like white means there is almost no correlation between the variables. So this was the bigger picture of the first part of the exercise, which I just covered in this short video.